Okay, just a second. We'll start in a minute. Yes, I is my screen clear to you?
Yeah.
You can see.
Yes, sir. Yes, sir.
Is this background good or I should change it to another? I have the options also. Let me show it to you.
Okay.
We can have a black background also if you want it.
No, this is good,
Hmm?
sir. I feel like this is better
Like this.
margin. Yeah.
Sometimes the student demand it because the white light used to have a bright effects over our eyes. That's
Yeah.
why. Is this okay or I should change it to previous one?
The previous one is okay.
Previous one is okay? Yes. Is this okay?
Yeah.
Okay, okay. So we are going to start. See, in the last class, what we had seen, let me write the topic here. We were studying the AC. Okay. This much is sufficient. Okay. In the last class, we were seeing about the AC. In the alternating current, what we had seen about is that we had derived the two equation. Do you remember that? That one was E of
Yes.
t, that was NB A omega sine of
I know.
omega t. Do you remember this? And another one
Yes, sir.
was one more, that I of t, that is when this AC voltage, this is the voltage, E of t is the voltage. We had seen this, that when we had connected this voltage with the resistor, what we had seen is that the current passing through it, that will also be a variable, because if E of t is variable, so R of t will also be a, sorry, I of t will also be a variable.
Yeah, I
And
remember.
uh, that was E of t divided by R. That was simple Ohm's law, V by R. Okay. And we can write
Yeah.
it as NBA omega sine of omega t and whole divided by R. Yes or no? We had
Yes,
seen all these
sir.
things in the last class.
Yeah. Yes, sir. Sir,
And
I had
yes,
informed about the to start with moving charges, right? Because I needed that for my test that's coming up.
you had said this to,
Yeah.
no,
I had told
actually,
to you before.
yes, yes, you had told me about, but I had also said you that let me complete this chapter. This will be completed very soon, and then we'll move to moving charges. Actually, when is your examination?
Actually, my half yearly is September end, but then August, like August 18th, I have a class test for that chapter, fourth chapter.
In August 18th. Till that time, we'll be able to complete it very easily. And not even
Okay.
that, even a lot other chapter also. Okay. Switching
Okay.
from one chapter, leaving it in between and switching it to another chapter, I think that this is not a good idea, because
Yeah.
uh, we are going to forget this. If we'll leave this after some time, it will be hard for us to recall this again. Okay.
Yeah.
So
Okay.
actually, let us first of all complete this. This will not take a lot of time, because most of the things is something like, as you had already studied about the current electricity. So it will not take a lot of time. Okay.
Okay.
So
Yeah.
actually, let's come on to the topic again. So what I'm going to do is that I'm not going to write this big expression again and again. I'm going to replace this with a E naught, with a E naught. E naught means E naught is a constant. Okay. And this term, I'm going to replace it with I naught. I'm going to replace it with I naught. Now, from the next time, whenever I'll write E of t, I'll simply write it as E naught sine of omega t, and I of t, I'll write it as I naught sine of omega t. Do you understood this? Is this okay?
Yes. Yes, sir.
Okay, so we had seen this, and I had also said you one thing in the last class, while deriving the equation, that we had derived the equation at that time, but we had not seen the mechanical setup. Yes or no?
Yes, sir.
So today we'll see the mechanical setup of this, because actually today we have much more time. So we'll be able to
Yeah.
see the mechanical setup. So actually it is a 3D setup, and most of the classes, most of the time teachers don't used to go derive, get deep into inside it like this. They used to just derive it with the mechanical setup, that this is this and this used to rotate and generate the EMF. But I'm not going to do that. I'm just going to derive it by you only. Okay, so just be with me during the time, because it is going to be a little tedious, but I'm still taking the risk. Okay, So what we are going to do is that suppose that let me take this. Okay, you will be able to imagine it. Okay, this is, there's one more thing, this. Okay, and okay, so can you imagine this to be a table? Is it
Yes,
looking like
yes, sir.
that?
Yeah, it does look like a table.
Okay, okay. It is looking like a table. Now, what I'm going to do is I'm going to make a setup something like this. Just try to imagine it that what I'm going to do is that there is a circular loop which is parallel to this table. There is this circular loop which is parallel to this table, and
Yeah.
which is not on the table. It is actually above the table, something like this. Can you imagine it? Can you
Yes, sir.
imagine the mechanical setup? What I'm going to draw it here is that the things are something like this. Okay, and apart from this, there are, obviously we are going to set up the magnetic field also here. And for the magnetic field, I'm going to simply take two magnets only. I'm going to take the two magnets only. So let us assume this to be a north pole and this to be a south pole. And what is going to happen here is that this loop, we are going to rotate it something like this. We are going to rotate it something like this. Now,
Okay.
can you imagine that if this loop will rotate, so the flux passing through this loop is going to change? Yes or no?
Yes.
Because there is a constant magnetic field that is directed from north pole to south pole, and it
Yeah.
is passing through the loop. So there is something, there is some area also, and we know that the flux is written by flux equals to B dot A. Do you know that?
Yeah.
So what is going to happen here is that when we are going to rotate the loop, actually the flux passing through the loop is going to change. And if the flux passing through the loop is going to change, we can definitely say from the which law that the EMF is going to induce. Which law states this?
Faraday's law.
Yes, Faraday law says that if you are changing the EMF, then definitely there is
Current.
the magnetic EMF going to induce into the
EMF.
loop. And if the EMF is going to induce, so it's very obvious that there will be definitely some resistance of the
Current.
loop also. And if there is
Resistance.
a resistance, so current will pass through it. There is no issues with that. Okay. So
Yeah.
now let's see. Let's what I'm going to do is let us assume that initially our loop was something like this. After take something takes take a numeric value, take a numeric value that let us assume that its time period is 12 second. Its time period is 12 second. 12 second means that in 12 second what is going to happen is it is going to complete one complete rotation. Yes or no? Time period, does this mean the same thing?
Yeah. It's gonna complete one
Yeah.
rotation in
Okay.
12 seconds.
One complete rotation, that is count as a time period. Now, what I'm going to do is because this is a symmetrical loop, will not get to know that where this actually loop had traveled after some time. So what I'm going to do is I'm going to mark this point A here, where we are going to do the analysis. Where we are going to do the analysis. So
Yeah.
we are marking the point A here. Now, what is going to happen? Initially, the point will be here. Do you agree with me over this?
Yeah.
This point A is away from us, away from you,
Yeah.
away from me also, and this point
Yeah.
okay, this point is away from us. Okay, now after okay, how much degree does it require to complete the one rotation?
What do you say? Could you repeat, sir? One
How much
rotation, yeah,
degree?
360. 360.
360 degrees required for to do
360.
the complete rotation. That means if this loop will complete a 360-degree rotation, that means a point will come in its initial position. So what
Yeah.
can you imagine that what will be the position after, let us assume that this is at t equals to 0, after the t equals to 3 seconds. Can you imagine that how the loop will look like? Can you imagine it?
It'll be, what do you say? Yeah.
It will
It'll
be
be in
something
angle
like
of 90
this or no?
degrees.
Yes, it will be
90
directly
degrees.
in the plane of our screen. Yes or no?
Yeah. Yes.
After traveling a 3 more second, it will again become something like
Yeah.
this. Yes or no?
Back.
It will again become something like this, but there will
Yes.
be a change. There will be a change. What the change is going to be, that after traveling 3 seconds, this point will reach to this point. Yes or no?
Yeah.
After traveling 3 more seconds, this point will reach to this point. That means it
Yeah.
is now
Facing
towards
us.
us. Yes, it
Yeah.
is towards us. Previously at t equals to
Yes.
0, it was away from us. Now
Yeah.
after traveling 3 more seconds, again the configuration of loop will be something like this. Yes or no? Yes or no?
Yes. Yeah.
And
Now
the
A will be
position
on
of
the top.
point A will be on the top.
On the top.
Yes, you are
Yeah.
doing very good. You are with me during the analysis, and that's the most important thing required right now. After
Yes.
3 more seconds, the loop will be again becoming the same rotation, and this will be t equals to 12 seconds. Yes or no? And the position of point A will become again same. Yes or no?
Yeah.
Okay,
Yes.
what I'm going to do here is that I'm going to take the two directions. Let us take this direction and let us take not this direction. Let us take this direction. Okay, uh, let's take it a little properly. Yes, I think this is good. Okay, what I'm going to do is I'm going to mark this current to be positive and this current to be negative, because they are facing in opposite direction. So one will be positive and another will be negative. Okay, now
Yeah.
tell me one thing. While it is rotating, that means in the initial position, the flux through the loop is the maximum, because the maximum area is facing to the towards the magnetic field. Yes or no?
Yes.
And if it will rotate, the effective area facing the magnetic field will reduce. Yes or no?
Yes.
If the
Yeah.
effective area facing the magnetic field will reduce, what this loop will try to do? From the Lenz law, we can say that it will try to increase the downward flux. Yes or no?
So what? Could you repeat again?
Uh, See, I'm repeating it again from the starting point only.
Yeah.
Initially, it is facing the maximum area. Yes or no?
Yeah. Yes.
So the maximum flux is reaching from upwards to downwards, that the magnetic field is reaching from upwards
Yeah.
to downwards. If
Yeah.
it will rotate in the position as we are showing it here, what is going to do? The effective area facing the magnetic field will reduce. Yes or no?
Yes.
So the flux going from upward to downward will decrease. Yes or no?
Yes. It will be.
If that flux will decrease, the loop will try that the flux should not decrease, and it will induce the current in the same way that the magnetic field due to that current should be in the downward direction. Yes or no?
Wait, I didn't understand the last part, sir.
See,
As in,
be with me. Okay,
yeah.
the again I'm repeating the again from the very start, man. Just the
No, so the
one
start. I
thing.
understood the start until
Yes, yes.
you said
No,
that
no.
it will
There
try to.
is. It will
It
try
will
to
try to.
increase the downward flux, because the downward flux is
Yeah.
decreasing. Yes or no?
Yes.
If the
But then
downward
how?
flux is decreasing, then the current in the loop will be induced in such a way that uh, the magnetic field due to that current should be in the downward direction, should enter in the loop from upwards to downward. Yes or no?
Yeah. To oppose it, right?
To oppose it, because the loop does not want that the magnetic field should decrease, because it is having a maximum flux in the downward direction, but the loop will try
Yeah.
to maintain that thing. Okay, so for that,
Yeah.
do you think that the current will be induced in this direction? You can apply the right hand
Yeah.
thumb rule and can see that the magnetic field due to this current now will be in the downward direction inside the loop. Yes or no?
Yes. Yeah.
Now, tell me one thing. After reaching to this point, after reaching to at t equals to 3 seconds, the effective area facing the magnetic field will decrease. That will be zero. That will become zero.
Yeah. So
Yes
flux
or
is
no?
zero.
Flux is
Yeah.
zero. Now, as it is rotating, that is, it is moving from second position to the third position. This is the second position, and this is the third position. This is the first position. Okay, from the second position to the third position, what is going to happen here is that the effective area facing the loop will going to increase slowly. Yes or no?
Yeah.
That means downward flux is going to increase,
Yeah.
but the loop will try that the flux should not increase, because initially at t equals to 3 seconds, the flux was zero.
So, I think I can't hear you right now.
See, you can't hear me? You can hear me. Uh, Now can you hear me? Hello, can you hear me?
Oh yes, yes, sir.
See,
Yes, sir.
from the second position, the now is it in the position second. So from the second position to the third position, the area facing the magnetic field will increase slowly. Yes or no?
Yes.
If it is going to increase, the flux going inside the loop will going to increase slowly. Yes or no?
Yes.
But can you tell me what the flux was at t equals to 3 seconds? How many magnetic field was entering inside the loop? There was zero, because
Zero.
because none of the magnetic field was entering
Yeah.
inside the loop. So what
Yeah.
the loop will try to do, as it is going to increase the loops, increase the area slowly, it will try to induce the current in this direction, so that it should nullify the
Yeah.
increasing magnetic field. Yes or no? Okay.
Yes.
Now slowly what is going to happen? It is going to reach the position A. Yes or no? Sorry,
Yeah.
position A, I mean the third position.
Okay.
Okay. It is going to reach the third position. Now tell me,
Hmm.
at the third position, what is going to happen? That the downward flux is the maximum. Yes or no? As
Yeah.
it will reach from third position to fourth position, what is going to happen here is the area facing the magnetic field is going to decrease. Yes or no?
Yeah.
If the area facing the magnetic field is going to decrease, so the point A will induce the current in such a way that this should not decrease, that the direction of the current should be this. Yes or no?
Yeah.
Okay. So that the downward flux should not decrease. Understood? And
Yeah.
in the again position A, you can see that the flux will be in this position only, as we had seen above. Okay. Can you imagine this also?
Yes.
From the third position, did you understood the third position? At the
Yes, sir.
fourth position, from fourth position, if it reaches the fifth position, again I'm going to say the same story, that the magnetic flux at the fourth position is zero, and slowly the magnetic flux is going to increase as it will reach from fourth position to the fifth position. Yes or no? If
Yes.
it will increase, so point A will try not to increase that. So as a result, it will direct the current in this direction. Yes or no?
Yeah.
Did you understood this? See, now
Yes.
what we can see here is, oh, acha, actually, I think that there should be amendment in this. What the amendment should be, that at t equals to 0, the loop is in a stationary position. That means it was in rest. And if it was in rest, that means the flux was not changing. Okay, so instead of t equals to 0, I should write t equals to 1 second. That is after an instant, during which the loop was moving, because at t equals to 0 the loop was stationary and the flux was
No
not
effect.
changing,
Yeah.
so no emf will be induced. That is
Yeah.
why I'm writing it as, instead of t equals to 0, I'm taking it at t equals to 1. Did you understood this?
One. Yeah.
And instead of 3 second, I'll just take 4 second. Instead of 6 second, I'm going to take it as 7 second. And instead of 9 second, I'm going to take it as 10 second. Understood? And
Yeah.
this will be the 12th position, although it is not required, because this fifth position is the same as the first position. Yes or no?
Yeah. Yes.
So that is why I'm not writing it here. Okay. Or just take it as 13 second. Okay. And the direction of current will be same. The same story I'm going to repeat it again and again. Okay. So the position of the first is same as position of fifth. So I think that we had completed the one complete rotation. Yes or no?
Yeah. Yes, sir.
Now just answer me this, that in this the current will be treated as positive because of this convention that we had drawn the arrow here. Yes or no?
Yeah.
At fourth position, the current will be again taken as positive. Yes or no? At
Yes.
t equals to 7 seconds, the direction of current will be taken as negative. T equals to 10 seconds, again the direction of current will be negative. Yes or no? Okay. Do you agree with me over this? Okay,
Yes, sir.
okay.
So
That's
so
great. But
basically
I
the current should, it should flow in such a way that it's going along the direction, not to south.
Yeah, see, from this analysis, what we had concluded it that the direction of current changes. Sometimes
Yeah.
it is positive, sometimes it is negative.
Negative.
Okay.
Yeah.
Okay.
Okay.
That is the only thing that is required. Now see, do you remember this, that what we had derived the equation E naught T, E naught sine of omega naught T? Yes or no?
Yeah. Yes,
In
sir.
the last class, I told you the formula that time period is 2 pi by omega. Had I told you about this?
Oh no. No, sir.
But I think that you remember
Yeah.
it. I expect that
Yeah.
you must remember this.
Yes, sir. I do
Okay.
remember.
Good, good. If you remember this. So the time period is 2 pi by omega. Can you tell me that what the time period was here? It was 12 seconds.
12 seconds.
Okay. And if we'll put the value of t here to be 12 seconds, can you tell me what the omega will be? That will be pi by 6. Should I write it directly?
Yeah, yes, sir. Yeah.
Okay, okay. Pi by 6. What is the radian of, oh, sorry, what is the unit of omega?
Omega is radian, right?
Radian per second.
Per second.
It is,
Yeah,
yes,
radian
radian per
per second.
second. Okay, it is omega here. Now, just we are going to replace, actually this is omega naught. So we are going to replace it in the original equation of E of t. We are going to replace this in the original equation of E of t. It will be E naught sine of pi by 6 t. Understood?
Yeah.
Okay, okay. Can you draw the graph of this? Acha, tell me what is its time period will be 2 pi. Its time period will be, because sine have a
Yeah.
time period of 2 pi. Okay.
Yeah.
Just tell me E of 0. E of 0 will be, can you see it directly?
E of
I'm
0
just
will
putting
be,
the t to be 0. Yes.
yeah.
E of 0 will be,
So E of 0 will be, it will be 0 itself, right?
yes, it will be 0. E of 3 also. E of
E of
3 also. Okay.
E of 3
3
will
will be,
be, wait, why 3, so sine 60,
sine 60
root 3
not,
by
it
2.
will not be a sine 60. It will not be
It won't
sine
be sine
60. It will be pi by 2. It will,
It will be
if
pi
we'll
by
put
2.
the,
Oh yeah, yeah,
yes,
3 by,
it will
yeah.
be pi
So
by
it will
2
be
and the answer will
1,
be E naught. Okay.
E naught, yeah.
6 seconds. I'm writing it directly. I expect that from the first class, I'm expecting that you will remember all these things. Okay. What will be the E of 6?
E of 6 will be again 0.
0. Yes, because sine pi is 0. Okay.
0.
What will be E of 9? Now,
E of
let me write
9.
this.
Yeah.
Let me write this. Pi by 6 into 9. Okay. We'll cancel it out. And E naught sine of, if we'll cancel it out, 3 2s are 6 and 3 3s are 9. 3 pi by 2.
3 pi by 2.
What is the value at 3 pi by 2? It is,
Value at 3 pi by 2. It is root 3
see,
by 2, yeah?
no,
60.
it will not be
No?
3 by 2. See, I'm just telling you one thing. Always remember this. Okay. Although this is a topic of mathematics, but I'm still telling you. See, just for the sake of sine and cos, I'm just telling it for the sine and cos. Okay. See, actually, here, I'm writing it for sine. It will be 0. Here,
Yeah.
it will be 1. Here,
Yeah.
it will be 0. It will be
Yeah.
-1. Okay. What are the angles here? It is 0. It is pi by 2. It is pi by 2 plus pi by 2. That is pi. And it is 3 pi by 2.
3 pi by 2.
Okay. 3 pi by 2. And it is 2 pi. Now, what is the, at 3 pi by 2, you can see it is -1. Understood?
-1. Yeah.
Yes. And if you talk about cos, so should I write it for cos also? Although it is
No,
not
sir.
required.
Yeah.
Okay. So actually cos of 3 pi by 2 will be 0. Now see, E of 9 is minus of E naught, and E of 12 will be, can you see it directly from the expression? What is the angle
E
going to
of
be
12,
inside the sine pi?
that will be 2 pi, so it will be 0.
It will be 0. Good.
0.
Now what I'm going to do is I'm going to draw the graph here. If I'm going to draw the graph will look like something like this. Okay, this will be the axis. See, the graph will be something like this. The graph will be something like this. At t1 time period will be completed at 12 seconds. This will be the between, that is 6 seconds. This is will be at 3 seconds. This will be at 9 seconds. Yes or no?
Yes, sir.
This maximum amplitude will be E of naught, and this minimum amplitude will be
Minus E.
minus of E naught. Okay, can you see this? Tell me, at t equals to 1 second, what can you see that the EMF is positive or negative?
Positive.
Have you derived the same thing above here just by the direction, by the Lenz law without
Yeah.
using any mathematics? Yes or no?
Yeah.
At t equals to
Yeah.
1 second, was the current positive?
Yeah.
Now tell me again, t equals to 4 second will be somewhat here.
Yeah. That's
At
also
t equals to
positive.
4 second, can you see that the EMF is again positive?
Yeah.
Had you derived the same thing when we had derived without using any mathematical equation, without using anything, just by the Lenz law and the by the Faraday law? Have we derived the same thing that at t equals to 4
Yeah.
second the current was positive? Now
Yes.
tell me again, at t equals to 7 second, can you see that the current is negative or EMF is negative?
Yeah.
Have you derived the same thing at t equals to 7 second?
Yeah. Negative. Yeah.
Now at t equals to 10 second, can you see that the EMF is negative? Have you derived the same thing above? That at t equals
Yes.
to 10 second, the EMF is negative.
Yeah.
Understood? So this is how the EMF is being generated. This requires a quite more 3D visualization. That is why I was not taking it in the first class, because sometimes many of the students are unable to even memory, I can't do anything here. If you can imagine it, then only you can find the direction of the current. Otherwise, you will not be able to find the direction of the current, because we are sitting here virtually. I cannot even show you the 3D models here. Okay, so that is why from the first class I had taken the risk that you might understand this. That is why I had taken this topic. Okay, otherwise many of
Yes,
the
sir.
people
I
used to
understood.
just derive this equation and just show it from the equations, that from the equation we can see that the EMF is moving sometimes positive, sometimes negative, but we derive it from the mechanical setup also. Understood? So this is how the EMF is AC current is being generated. And do you remember that I had said the one statement here that we are rotating this loop particular. Okay. So the first question must arise in your mind that how we are rotating this, why we are
Yeah.
rotating this. So actually why to is, it's very easy that
Yeah.
we must rotate is
Same
only
thing.
then the
Yeah.
AC is going to be generated. The how, the reason for the how is, or the answer for the how is, we used to do you know about the dams that is being built over the rivers?
Yeah.
Whenever the water falls from the high height, so what is going to happen? It used to fall over this. Just take me a
Yeah. To
different kind of
spin
marker.
the thing. Yeah.
Yes, it used to fall over one of the edges here. So because
Yeah.
of which, what used to happen is this loop used to rotate.
Spin.
This loop
Yeah.
used to rotate,
Rotate.
and we use that mechanical energy to convert into electrical energy. Understood?
Yeah.
Okay. So
Yes.
this is how we use many other setups also, like, but the dam is very popular one. We use dams, we use the windmills also. What the windmills used to do, we used to build the big wings, because of which if the air flows, that particular wings used to rotate. Have you seen that in the pictures?
Yeah. Yeah. I have seen.
So because of that, that particular turbine is being rotated, and we only require the rotation here for to generate the EMF. There's nothing else required. So there are very if you'll just go near or just research over it, so you'll find that there are very big magnets used to being implemented over the dams for to generate this electricity. The purpose of the dam is not only for to stop the water and save some areas from the flood. It is not the only purpose. The purpose is this also. If we are sitting in the house and we are having the electricity, the reason behind that is those dams and those windmills. Although windmills are not popular here in India, and although it's not popular, I think there also, right?
Yeah.
So
Yeah. It's
we
not
used
fun.
to uh, build generate the EMF by this particular purpose. Understood? Should we move
Yeah.
ahead? I think
Yes,
this
sir.
much of sufficient information is being given over this. Now let me show the exact diagram, because in the exam you are this is good for the understanding purpose. In the exam you must not draw this. In the exam there should be a complex diagram. Let me give it to you. Let me see if I can copy paste it directly, because I'm not going to draw it here. Okay, because that will save our time. Let me see if I can paste it here. I think I can. Yes, I can. Can you see this picture here?
Yes, sir.
Can you see this picture here?
Yeah.
Good. See what the setup is actually here. Uh, I can write it also over it. See, these are the. I'm talking about the figure A only. I'm talking about figure A only. Okay. And just have a look of the figure A. This is the south pole here. You can see S over written there, and this is the north pole here. And these are the large windings. Because do you remember in the formula of EMF we used to write a notation N there? What that N represents?
The number of going on.
Number of turns. The higher the number of
Yeah.
turns, the higher the EMF will be generated.
Yes.
Because of that, there is a large number of turns over here, and this particular thing is called as. Uh, yes, I can write it. This okay. Yes, let me change the pen. Yes, this particular thing is called armature. This is called armature. Okay, so there is a large number of turns here. Copper wire we used to use mostly. These are the large number of turns, and these are the magnetic poles. I'm not donating it here, writing it here. This is the south pole, this is the north pole. There is a constant magnetic field directed from north to south. You can also see this small arrow here, okay, that is pointing from north to south. Understood?
Yeah.
This is here, and these are the split rings. Can you see this? These are the split rings.
So those the blocks B1 and B2, those are part of the split rings, or are those something else?
Okay, just let me come over that, I'll explain it. Okay, split rings. In the both the figures there are the split rings. Okay, I'm just writing it over in the one only. Okay, it is actually present in both the figures. These are the split rings. What the split rings used to do, uh let me draw it here. Okay, this is actually see, you can see this line here, moving line here.
Yeah.
This line is connected to the lower split ring. Do you understood this?
Yeah. Those
This
split rings.
line is connected to the lower split ring, and there is one more line that is being, can you see this line?
Yeah.
That is connected to the brush B2. B2 is the brushes. B1 and B2 are the brushes, carbon brushes that is just being touched. Well, we had seen that toothbrush. It is
Yeah.
simply like that only. It is just being touched over
Okay.
that for to maintain the electrical conductivity. Okay. Now
Okay.
what used to happen is as we are rotating this loop, this particular thing, this particular, can you see this moving line here?
Yeah.
It is right now touching to B2. What is going to happen when the loop is going to rotate? This particular line used to rotate in this split ring S2 like this. Understood?
Yeah.
Can you see this?
Okay. Yeah.
This split ring used to, this particular line used to rotate like this. And similarly, in the above, the direction of this is this, and this used to rotate over this. Why this is we are doing there is because if the loop will rotate, the if we'll just fix it to a one point, that is not going to be the joint properly, that will just get detached after the one rotation or two rotation. Understood? So because of that
Yeah.
we used to make this kind of setup so that this can slide over this. Understood?
Yeah.
Yes. Okay, this used to happen. And in the same way you can see for half of the loop, the current in the resistor R is in pointing this direction from towards the left direction. Okay, can you see it? And in the B figure, you can see that
Goes to the left.
are you seeing it that after a half rotation, that this line, I'm
Yeah.
drawing it
It's
again.
on the, yeah,
See,
on the
you
bottom
had seen this,
side.
that this line has reached to this position. This line
Yeah.
has reached to this position. Can you see it?
Position. Yeah. I
Yes.
can.
And the above line has reached to this position.
This position.
Understood?
Yeah.
This position. Okay. I'm drawing it
Okay.
big here. Did you
Yeah.
get that? Okay,
Yeah.
okay. So this is how the mechanical setup looks like. So the actually required thing here is to just the required thing here is to rotate this loop. Understood? Should we move ahead?
Yes.
Let me mark this also. These are called the carbon brushes. These B1 and B2 are called the carbon brushes. Carbon brushes. Leave some space in your notebook. You should draw it after the class. Okay.
Yeah.
This is the whole setup. If in the exam if it comes, so you should draw this. Okay, and this is the most simplified way of drawing a a particular generator. Okay, this generator is also called generator, electric generator. It is called electric generator and also termed as dynamo. Its fancy name is dynamo. Okay, electric generator or dynamo. And what else we can say? We can write the principle here. Okay, let me write first of all. It converts one form of energy to the another. If it is generating electricity, then definitely it is converting one form of energy into another. Do you agree with me over this? Because energy can neither be created nor be destroyed. We know it. Okay, so which form of energy is being converted to which form?
Mechanical to electrical.
Yes, it converts mechanical energy
To electrical.
to electrical energy. Yes or no? Okay.
Yeah.
And the principle behind this is how it is doing it. How it is doing it?
To the carbon rings.
How it is doing it? What is the principle behind that?
Is
Electromagnetic
all due
induction.
to
Okay.
induction.
It is electromagnetic induction. Now I think that there is no problem while understanding about this. Yes or no?
Yeah. Yeah. No
Should we
problem.
move ahead?
Yeah. Yes, sir.
Okay. Okay. Now see, till now we had seen this. Now we'll again come back to the original equation that was E of t, that was E naught sine of omega naught t. Okay, but this is not the perfect equation. Actually, there is an amendment here. What is the next change in the equation is at t equals to 0. Actually, what is this? This is the angle. Do you remember that in the last class we had written at theta equals to omega into t, where theta was the angle between the magnetic field and the area vector? Yes or no? So this is angle between area vector and magnetic field at time t. Yes or no? At time t. It is the uh, angle between the omega naught t is the angle between the area vector and the magnetic field at time t. But suppose what we in the till now we had taken is that initially the angle that is the plane the direction of area vector and the magnetic field is 0 or 180 degree. Till now we had taken the same thing in the example also. In our example also, what I had taken is here is you can see that the area vector and the magnetic field are either in the 180 degree or in the 0 degree always.
Yeah,
Okay, but this should not be the always case. There can be different angles also. So because of that, we used to write the equation like this, that E of t is E naught sine of omega naught t plus phi, where phi is the initial angle. Phi is the initial phase or initial angle.
So could you explain it with like an example?
For example, suppose we can take the same thing here. Okay, just come back to the our original example here. See, at t equals to 1 second, so at t equals to 1 second, the suppose that the area vector is pointing upward. What is happening? That the area vector is pointing upward. Okay, and suppose the magnetic field is pointing downward. Okay, so if the area vector is pointing upward and the magnetic field is pointing downward, there is a direction of there is an angle of 180 degree in between them.
180. Yeah.
Okay, now tell me here in the if was it the mandatory thing that we should start from that position only? Can we start from the second position? We can start from the second position also. So now tell me, what is the angle between here? The area vector is pointing towards us. Yes or no?
Yes.
So we should write the area vector is like this, outwards.
Yeah.
Yes or no? And the magnetic field is in downward direction.
So
now what is the angle between them? 90 degree. So what will be the phi for this? Pi by 2.
By 2. Okay.
What will be the phi for this? That will be pi by 2. Okay, so actually phi is the initial angle. Initially, whatever the angle it is making, that we'll write it as phi. Okay, initial angle or angle between area vector and B at t equals to 0. At t equals to 0. Okay? Understood this?
Yeah.
So this is our complete equation for this. This is our complete equation for this, for the E of t. Now it is totally perfect and we do not require any kind of change here. Understood?
Yeah.
And I of t should be I naught sine of omega naught t plus 5. Understood? This is the I of t here. Understood? Okay, let's move ahead. Till now we had seen that the EMF is changing with time. Yes or no?
Yeah.
And I of t is also changing with time. Okay.
Yeah.
So if you're talking to someone, okay, like in DC, we used to describe our circuit that we had connected a voltage source of 2 volt there. We had connected a voltage source of 3 volt there, like this. So that is a perfect way of talking. And if we are talking about AC circuit, we had joined the AC source. So should we say it like that, that we had connected a source of E naught sine omega naught t plus 5? This is not a right way. This is not a perfect way of describing a particular circuit. That is why we used to define a different nomenclature for this. That is, for that we used to define the different values of this particular varying AC, and what the different values will be. That is, some of them we had covered in the previous class also. I'll repeat it again because it does not take a lot of time. Instantaneous value. Instantaneous value will be given by the equation itself. Instantaneous value will be given by the equation itself. That is, E of t will be E naught sine of omega naught t plus 5, and I of t will be given by I naught sine of omega naught t plus 5. Yes or no? This is the instantaneous value. At any instant, if we require the E of t, we'll just put the value t there. And any instant we require at I of t, we'll just put the value of I of t time there and we'll get the value. Okay, so this is described by the instantaneous value. There is one more value, that is the maximum value. There is one more value, that is the maximum value. Maximum value of it will be defined by, you can see that maximum value will be E naught. Yes or no? And that we know that that is NBA omega. Yes or no?
Yep.
Maximum value is E naught NBA omega. And we know about I naught also. Maximum value is NBA omega whole divided by R. Yes or no? Understood? This is the maximum value. We can also derive the second, the third, actually.
Sir, you will be sending this notes right after the class?
Yes, I'll be sending you.
Okay.
I'll be sending you over the, you can contact me over the WhatsApp also. Okay. I'll be sending you the notes there. Maximum value. The second is average value. And during the session today, I'll give you the homework also. During the session, if you get any kind of problem in the homework, you can ask me directly on my WhatsApp also. Okay. Not need to wait for exactly the class after 1 day or 2 day, whatever the frequency is. You can ask me there also. I'll clarify you in how much extent it will be possible in the online, just on the text. Okay. Otherwise, we'll discuss in the next class. And now we are over the average value. Okay, average. Do you know that how a average of any function of the mathematics is being defined? Do you know about it?
Yeah. Sum
Hmm?
of all the values
Sum
divided by
of
the
all the
number of.
value divided by number of the value. But is that true for the continuously varying signals also?
No.
That is good
Yeah.
for the discrete values. If I had
Yeah.
given you the
Discrete
discrete
values.
values, then the average you can define it by sum of the all values divided by total number. Although in continuous values, try to see there is not a big difference in between those two things. You should try to just get the what the output will be in the varying signal by that method only. Okay, sum is actually what it is, the integration. It is the integration.
Integration.
Understood? So we'll
Yeah.
just replace it by the integration. There is nothing else change. Okay. if
Yeah.
f of x is a periodic signal, let's not take it as f of x, we should take it as f of t, because f of t is a periodic signal. Periodic signal means
Like the value at that period of time.
periodic signal means which repeats after a certain interval of time.
Yeah.
Okay, there could be a many kind of signal. Maybe it doesn't repeat after a certain interval of time. That is why we'll say if it repeats after a certain interval of time. If f of t is a periodic signal, so its average value, f of t average, will be defined by f of t dt from time interval 0 to t, where t is the time period. T is the time period. Okay, f of t, this is the sum of all the values divided by total number of values, that is 0 to t. Understood? This is how we define used to define it for the for any varying signal. Understood? Now see what the next we are going to do here is do you know what the average of sine is? I'm asking it directly.
Sir, what average of?
What the average value of sine is?
Average value of sine.
Hmm. Do you know it?
No, sir.
Okay. Just come here. Let's see. What the in the numerator we are writing f of t dt. F of t dt integration from 0 to t. This will be the time period t. This will be time period
Yeah.
t by 2. Yes or no?
Yeah.
So what is f of t dt? Don't you think that this is the area under the curve of the function f
Yeah.
of t and t? Yes or no?
Yeah.
So do you
And
think that this area is going to be positive and this area is going to be negative?
yeah, so then 0.
And both the values are equal. So the average is
0.
average. Let's not write it like this. Let's write it right. Let's sine of theta for uh, for we are writing it for 0 to 2 pi angle, where theta varies from 0 to 2 pi angle. Understood? The average will be 0.
0. Yeah.
Okay, we are writing average now. So average of sine theta for the average will be 0. So the average value of our signal will be 0 for the complete one rotation. If this is our signal, so the average value will be 0. But we can't define anything to be 0. Okay, so that is why we used to define it for half of the cycle. We used to define average for half of the cycle. Average for the half of the cycle will be definitely counted only for the positive one.
Yeah.
Only for the positive one. So for that,
Yeah.
if I'm writing E of t as E naught sine of omega naught t plus phi. Okay, so the average value will be, although average is donated by this, but I'm not doing the mathematics fancy here. Okay, so I'm just writing it like this. Average value will be 2 by pi times of E naught. Okay, you just read to this is the mathematical way of deriving this. I had given you the formula. If you want to derive it, you can derive it. Okay, but it is not required. I'm just giving you for the directly here. Okay, E naught is here, and I of t is being written as I naught sine of omega naught t plus phi. I naught was this. So the average value for this will be 2 by pi times of I naught is the maximum value. E naught is the maximum value. Understood?
Yeah. Yeah.
So this is the average how we used to define it. Understood? Okay.
Yeah.
See,
Okay.
now one more mathematical term is going to appear here. Okay, that will be new for you. Maybe it will be new for you, but if it is in the course, so I'll definitely take it. I cannot remove it. Okay, like we used to find the everywhere we used to find, what we used to find is that like we used to find the mean, we used to find the mode, we used to find the median of a particular data set. So once that was also new to you. Okay, so now the new mathematical term that is going to come here is the RMS value. Maybe I'm not expecting this now that you must know about this. Okay, but I'll tell you here. Okay, the third kind of value, these are all the values we used to define it for the AC signal. Okay, like for example, instantaneous value, the maximum value. We can define it that we had used a AC signal whose maximum value was E naught, whose maximum current was I naught. We used to define the circuit like this. And the average value, we will define it that whose average value was 2 by pi E naught for the half of the cycle. We'll define that its average current was 2 by pi times of I naught for the half of the cycle. Similarly, we are going to define the RMS current here. Oh, sorry, RMS value of a signal. RMS value of a signal. Okay, if it is the RMS value, again, I'm first of all going to give you the generalized formula that I had given here in terms of f of t, and then we'll see that what will be the answer in our case for the particular signals. Okay.
Okay.
If we have a signal f of t that is periodic, again, I'm talking about the periodic only. Its RMS value. RMS, and RMS stand for root mean square. Root
mean square.
Mean
Okay.
square. Have you listened this before?
No.
It is the root mean square. So actually the name itself suggests that how to compute it. Okay, we'll can compute it right now. F of t, if RMS value, root mean square value will be f of t RMS. First of all, what you have to do is you have to take the square of a particular signal. Understood? Then
Okay.
integrate it for the time 0 to t. Does it look like, and divide it by dt from time 0 to t? Does it look like the same thing that we had done while finding the average? The only difference is that there was not the square. Okay, there was not the square, and in the name comes root mean square. We had used the mean terminology here, we had used the square terminology here. The next comes the root. So the root will be over this complete expression. Understood?
Yeah.
Let me draw it properly. Okay, the root will be on this complete. Just a second. The root will be over complete this expression. Understood? This is how we used to find the RMS value of any particular varying periodic signal. Okay, it is not confined for this particular signal that we are studying here. It is valid for any periodic signal. Okay, but in our case, as we know that E of t is E naught sine of omega naught t plus phi, and I of t is I naught sine of omega naught t plus phi. We'll see the RMS value. E of t RMS value will be the maximum amplitude divided by root 2. This is the most important thing. The maximum value divided by root 2. Understood? And the RMS value for the current will be again the same thing. The maximum value divided by root 2.
Okay.
This is the nomenclature that everybody uses. I'll give you the live example of this. Can you see this too? Whenever someone asks me about, like, see why we had defined it. Instantaneous value, it is not a proper way. I don't think that this is the proper way of telling anybody about our signal, that we had using the instantaneous value E naught sine omega naught t plus phi and all. Understood? This is not a proper way. Maximum value does not tell us about anything, that the maximum value is I naught. So it also doesn't tell us that how much the minimum value is.
Sir,
Okay.
1 second.
Yes.
I think my internet is.
Is this okay now?
Hello, sir.
Yes. I can hear continuously.
Yes, sir.
See, I was talking about that the instantaneous value is not the perfect way of defining any particular signal. The maximum value, again, the maximum value doesn't give us about the overall data of anything. Okay. The next comes the average value. Actually, the average value is 0. So we are almost defining it for half of the cycle. Then we are getting a certain value, that is 2 divided by pi into E naught. Understood? But again, we are having some restrictions over it, that we are defining it for the half of the cycle. So we used to define it separately. Okay. So because of which this is also not a perfect way. But the RMS signal is true. We are not putting any extra conditions over it. We'll just find that the RMS value of our signal is E naught by root 2. I of t, the RMS value will be I naught by root 2. Maximum amplitude divided by root 2. Understood? And actually, this is the see, should I tell you that what the how we had find it out? Although this is one of the formula of finding it out, I can derive it for the different way also. Should I derive it for you?
Oh, yes, sir.
Okay.
Yeah.
I think, see, if you're asking it, then only I'm deriving it. Otherwise, I don't used to derive it in the class. Okay.
Sir, is it a
See,
long derivation?
suppose, no, it's not a long derivation. Actually, it is, it feels good if you listen this, that why the RMS is being used. So I'm just telling you. Sometimes, okay, just let me derive it if you had asked me. This is R, and this is V of AC. We are using the potential, that is AC signal. Yes or no?
Yeah.
And here we are using a V of DC signal. Yes or no?
Yeah.
So
Yeah.
in DC signal, you can show the direction of current here. Yes or no?
Yes.
In DC signal, you can show the current here. Actually, I need to draw it a little downwards. Let me see if I can cut it here. Are you able to see this? What I'm
Yes,
doing
sir.
it here is okay. Yes, I can do this here. I'm also learning this platform with you. Okay. I know we used it a lot, but I'm learning this with you. Yes. I'd learned one more thing here. Okay. Now let's come on to the topic. We were talking about that we had joined a AC signal with the resistor R, and we had joined a DC signal with the resistor R. Actually, in our real life, we always talk about the energy. What the current is coming, that doesn't tell us a lot of information. Why? Maybe what is the power of what is the formula for power? Power is, in terms of V and I, power equals to VI. Yes or no?
VI, yeah. Yes.
Power is VI. Or you can say V square by R, or you can say I square into R. Understood?
Yeah.
So if we are saying that power equals to VI, and we are saying that we are having a very high voltage, can you say that you are getting a very high power also?
Yeah.
Can you say this? Seriously?
If the voltage is high, then they're like directly proportional, yeah. So then power will also be high.
See, come here. When you are writing P equals to VI, I'm saying that V is very high. And if I'll say that I is very less, then what are you going to do? Will you still say that the power is very high?
No, then the power will
Without,
remain.
yeah,
Yeah,
no,
it'll remain
even
constant.
you
Yeah.
can't say anything. Not even
Oh,
say
like
that the
that. Yeah.
power will remain constant. If you don't have the information for I, you can't say that the power is high or less. Remember
Oh, so we
always
don't
this.
have the information for I.
Yes, we don't have the information for I.
Okay.
So
Okay.
if I'm saying you, I'm just giving you the information that the voltage is very high. That doesn't mean that the power will be high. Understood?
Yeah.
And
Yeah.
don't use this word that it is directly proportional. Learn it in the, I don't know that how you're studying the mathematics. See, if you are saying that power is directly proportional to V, this means that I is constant. Only then you can say that the power is directly proportional to V. Otherwise, you can't say that the power is directly proportional to V. Okay?
Yeah.
Because
Okay.
you don't know about the information for I. I had only said you given the information that the V is very high. Okay. So
Yeah.
if you're
Okay.
saying that the V is very high, so what does that mean? Can you say that the voltage is very high?
Yeah. Voltage is high.
Yes, voltage is very high. Can you say that the power is very high?
No.
No, you cannot say this. And
Mm.
power is similarly like the energy. The only requirement is that we should multiply it with the time period, with the time t. Okay, P into T comes the
Okay.
energy.
Okay.
You remember this, no? That the energy is P into T, or the heat is P into
Yeah.
T. Remember this in the current
Yeah.
electricity. You must have studied about all these things. Okay,
Yeah.
so just knowing about the power, the thing, the voltage or the current, you can't say that how much. You can't just think about that signal, that whether that is good or bad. So always we used to define the signal in terms of the energy and in terms of the power. Okay, so we used to compare the two circuits on the basis of the power. Okay, not on the basis of the values over the voltage. Okay, remember this always. Now see what is going to happen in this AC circuit. Do you agree that sometimes the current is going to be in this direction, sometimes the current is going to be in this direction? Yes or no?
Yeah.
And do you agree with me that in both the condition it is going to dissipate the heat like this, whether the current is going in this direction or
Yes.
the current is going in this direction?
Yeah.
In this particular circuit, in the DC circuit, the current is always going to flow in this direction. Okay,
Right.
and it is going to dissipate the heat. Yes or no?
Yeah. Yes.
Now, what we are going to do, we are going to compare these two circuits. For the comparison of these two circuits, what we'll do is that we'll calculate the power of this AC signal. Power of this AC signal will be in terms of V and R, it will be V square by R.
Yeah.
Yes or no? And in
Yeah.
terms of this DC signal, that will be V square again by R. Okay, okay. That extra time T will also be multiplied
Time.
here if we are
Yes.
dealing with the energy. Yes or no?
Yeah.
Okay. This VDC will be constant. Yes or no?
Yeah.
But this V of AC is in terms of time T. Yes or no?
Yes.
So we should replace it with its original equation. I should replace it with E naught square sine square omega naught T plus phi. Yes or no?
Yes.
Whole divided by R into
R.
T. Yes or no? And
Yep.
what is going to happen here is there will be a constant. So I'm taking the E only. Okay, E of DC. Let's take it as E of DC because I had written E naught here. That is why I'm writing at E of DC. V of DC is equals to
Okay.
E of DC. Okay, E of DC
Okay.
square by R into T. Yes or no?
Yeah.
Now just do you remember what the average value of sine of omega naught T is? It is not 2 by
Average
pi,
value
not
is
2 by
zero.
pi.
Yeah. Okay.
Average
Zero.
value is 0. Yes,
Zero.
average value
Yeah.
is 0. But sine square omega naught T, if you calculate it, you will find it out as E naught square divided by R into 1 by root 2 ka whole square into time T. E of DC square divided by R into T. Is this okay? If you will calculate this, compute this average sine square omega T, you will get it as 1 by root 2. Okay, I'm just giving you
Okay.
the information here right now.
Yeah.
Just remember is because if I'll jump into the mathematics, so we'll get little detached from the physics. Okay, so that is why
Okay.
I'm not jumping into the mathematics. I'm just giving you just for the sake of calculation. Remember it. Okay, and if you want it, we can derive it also, but I don't think that is required here. Okay, now
Okay.
just do the calculation here. If we'll do the calculation here, time T will be calculated by will be cancelled out.
Cancelled
R
out.
will be cancelled out.
Yeah.
Yes or no? And
Yeah.
if you will calculate it, E naught square by 2 into E of
Yeah.
DC square. Yes or no?
Yes.
Now tell me one thing, that what E of DC is. Is it not E naught by root 2?
Yeah.
It is E naught
It
by
is
root 2.
root 2.
What does this mean?
Okay.
This means that if in DC you are applying a voltage of E naught, you are using a circuit of E naught. In AC, you should use a voltage whose RMS value is E naught by root. Understood?
Yeah. Okay.
So it is actually for the comparison of these two circuits. Whenever we compare AC circuit and the DC circuit, we used to compare it with the RMS values. Okay. Just I'm
Okay.
telling you in the short here. Otherwise, this is the biggest big formula which everybody used to derive in the class. Just put the values. They'll. I am giving you a hint also. If you'll put the original value E of t here, so what you will get here is E naught square sine square omega naught t.
Sine square. Yeah.
Omega naught t.
Plus
Omega naught t plus phi also.
phi. Yeah.
Divide by dt. If you'll integrate this term here, dt term here, you'll just get the t time period here.
Yeah. 10.
Because do you remember this, no? D of t is nothing but t, integrating it
Yeah.
from 0 to t. Okay, this is the same thing.
Mm.
So you can solve it here. After replacing sine square omega t, how can you integrate the sine square?
Sine square will just be.
Can you integrate it directly?
Directly no. Yeah.
You need to apply a trigonometric formula here. Sine square omega naught t, you can find it out in form of cos 2 omega naught. Remember this?
Yeah.
Sine square theta is nothing but 1 minus cos 2 theta divided by 2.
Theta.
Okay, you will just replace it by this. Then after, if you will calculate it, the integration of cos 2 theta will become 0 and 1 by 2 will remain there. And after doing the certain calculation, you will get it out. Okay.
Okay.
So I'm not going into it, and I'll just give you the homework. Okay. So that is the E of DC here. We had find it out. So actually, it is a comparison of AC source with the DC source. Now,
Yep.
E of DC square. Yes, it is correct. Now, do you remember whenever you go in the market and buy a bulb there are the certain values over written it, 10 ampere and √2, 10 ampere, 220 volt. Have you seen this before?
Yeah. Yeah.
There are the certain values written over there, 10 ampere and 220 volt. What does this mean? This means that this bulb these are the RMS values. What is this? These
RMS
are the
values.
RMS values. These are the RMS values. Okay, these are the RMS value. If it is a RMS value, that means I'm talking about the current. If it is the RMS value, first of all, let's talk about the ERMS is 220 volt. Mostly you will find this to be written there. And ERMS is nothing but E naught by √2, where E naught is the maximum amplitude. Yes or no?
Yeah.
It is 220 volt. E naught is 220 into √2. That will be 220 into 1.414. Okay, the value of √2 is 1.414.
Yeah.
You know about it, na?
Yes. Yes.
Yes, calculate it. 220 into 1.414. 220 into 1.414. What is the value?
So 1 second, sir. 1 second.
Yes.
Yes, sir. 220. Uh, 220 into 1.41, it was 310.2.
310. It is 311.08 volt.
Yeah.
Okay.
Okay.
It is the E naught. Now, if I of RMS is 10 ampere. That means it is nothing but I naught by root 2 is 10 ampere. And you can say I naught is 10 into 1.414. It will be 14.14 ampere.
Yeah.
Yes. Now see, on the bulb, what the rating was written? 10 ampere and 220 volt. So suddenly, not suddenly, I mean generally, what the people used to think is that it can bear up a maximum current of 10 ampere and a maximum voltage of 10 220 volt. But it is the RMS value, the maximum current that this particular bulb can take inside it is 1.414 or 14.14 ampere. Is 14.14 ampere, not this 10 ampere. Understood? If it is written that 220 volt is written over the rating of the bulb, that means it can bear up a voltage of 311.08 volt. Understood? These are not the maximum values. Generally, people used to think that if we'll apply the more current or the current beyond the 10 ampere or above 10 ampere value, it will get damaged. So it is not going to damage. It can bear up a maximum current of 14.14 ampere and a maximum voltage of 311.08. Understood?
Yes. Yes.
So this is and this is these all calculations are being done over the RMS values only. Okay. So always remember this, that the RMS of a current is being represented by this. Even if you remember, do you know about the multimeter or the ammeter? You must not know about the multimeter. You must know about the ammeter or the voltmeter.
Yeah.
Ammeter and voltmeter. How from which particular one electronic component these two are being made?
So from which?
From which one electronic component both are being made, even the ammeter and the voltmeter?
Electronic component.
There is one component that can be transformed into ammeter and or in the voltmeter.
Oh, like, sir,
It
what do
is
you mean by electronic
galvanometer. It is
galvanometer? Oh, okay.
galvanometer. Don't you know that the galvanometer can be transformed into ammeter and the voltmeter?
No, sorry, not know that.
Have you not studied in the instrumentations?
Oh no, I didn't. I don't think I've learned that before.
In the instrumentation, the people used to derive it that how the particular ammeter or the voltmeter is being made by the gammeter by adding a shunt resistance in the parallel or in series. Don't you know about it?
Oh, yeah,
Yes.
by adding resistors. Yeah, yeah, yes.
Yes.
Oh, yes, yes, yes.
How I know it that how can you study the current electricity without
Yeah.
this thing?
Yes,
Okay,
sir.
so ammeter and voltmeter when connected with AC source. What happened to my writing? With AC source gives the RMS values. Okay, remember this always, that whenever you connect an ammeter or a voltmeter with the circuit, you used to get a RMS value of that particular circuit. Understood?
Yeah.
This is one of the point here. What else we can see? Okay, let me write some fundamental formulas here. See, do you know that time period is basic formulas? Let me write the heading here. Basic formulas. Basic formula, we can write time period is 2 pi by omega. Omega, you can find it out from the equation. Okay. Omega is the angular frequency. Angular frequency. And frequency is 1 by t. F is simply the frequency. Unit of omega is radian per second. Unit of frequency is second inverse. You can see it from here. Or you can also write it as S minus, or you can say it as to be hertz. Understood?
Yeah.
And if you will replace this time period formula in the frequency, you will get F equals to omega by 2 pi, and you will find it out omega equals to 2 pi F. Understood?
Yeah.
So remember these formulas. These formulas are important, sometimes being asked also. Okay. Just actually two of the things were required. Okay. If we learn any two, I used to remember this time period and frequency. Rest all the things I used to derive always in the question. Okay. So these are the basic
Okay.
formulas that you should remember. I think let's move on to some of the questions here. Okay.
Okay.
Let me see. I'm having some questions. Okay. Let me write one more thing here. Power of AC signal. We are doing it, so we should do it here only. Power of AC signal. Power of AC signal is defined by P average. Actually, average power is defined by VRMS into I of RMS. Understood? Power is
Yeah.
defined by VRMS into I of RMS.
Yes.
Okay, RMS values are taken, and if you take it in terms of E naught by root 2, and this will be I naught by root 2, this will be E naught into I naught by 2. Is this okay?
Yes. Yes, sir.
Just remember the first one, the last all can be derived by you. Okay, we can apply all the DC formulas also here. Power average, if we ask, so that is also V square by R. So it will be V RMS square by R also. Or you can say power average is I square, I RMS square into R. Understood?
Yeah.
This is how this works. Okay, I think this much is sufficient. We should move on to some of the questions. Let's take an easy question first. Not easy question. We'll derive everything here in the same question only. Okay, I'm just writing it thoroughly here. Let us assume that E of t is given as 300 sine of 314 t. Okay, this is given to E of t here. Find. First is maximum value. Second is omega. Not omega. Let's write angular frequency. Third is frequency. Fourth is time period. Fifth is RMS value. Sixth is average value for complete cycle. Seventh is average value for half of the cycle. Can we see anything else also here? Okay, just do it. What is the maximum value?
300.
Yes, and take V, this is in voltage. Okay, this is in voltage. So this is 300 volt. The second is, what is the angular frequency?
Oh, wait, what was the formula for angular frequency?
What is the angular frequency being denoted by?
No, here angular frequency will be 314, right?
Yes, 314. What will be the unit?
Radian per second.
Radian per second. What is
So frequency is.
frequency is?
Oh, 1 second, sir.
Take pi to be 3.14. If you require
Okay.
the pi, so take it to be 3.14.
So during the exam, do we have to solve it with taking the value of pi?
Yes, with the you will get to know about it if the questions are if the values are given something like 314 or 31.4 or in terms of 3, 1 and 4, then you must take the pi value to be 3.14.
Okay.
Okay, as you can see here, the value is given as 314, 314. But if nothing is given, then just go for 22/7. That is a better one. What is the frequency?
So frequency will be
What is the
0.02.
hmm?
0.02, right?
Before solving the third one, I think you should go and solve the fourth one. For the fourth one, what is the formula for time period? Time period is 2 pi by
2 pi by
omega.
omega, yeah.
Yes or no?
Oh, yes, 2 pi by
2
omega. So
into
that's
3.14 divided by
0.02.
314. Time period will be this will be 1 and this will be 100, and you will get
0.02.
1 by 0.02. Yes.
02, yeah.
And second. Okay.
Yeah,
And if I ask you,
I had used this formula to solve frequency by mistake, so that's why I got frequency as 0.0.
mistake is a mistake. Never treat it, take it lightly. Okay. Remember this from the next time, that the time period is 2 pi by omega. Okay.
Yeah.
Okay. What is the frequency? Now you can derive the frequency. Frequency is nothing but 1 by t. That is why I always used to say that remember the time period only, that is 2 pi by omega, only this and nothing.
Yeah.
Okay. If you'll remember the time period to be 2 pi by omega, you can derive the rest of the things also. What will be the
Yeah.
1 by t? That will be 1 by
1.1 by
0.02.
0. Yeah.
That will be 100 by 2, or you can say
Yeah.
50. What will be the unit?
This will be hertz.
Hertz. Yes. Okay. And do you know that what is the frequency in India? Actually, in UAE also the same frequency is.
It was 120, right?
No,
Something like that.
it is 50 hertz.
50 hertz. No.
Yes, 220 volt and 50 hertz.
Or 220 volt, yes. 50 hertz.
Okay. I should write in India. Okay, like in India, mostly the questions are being asked like this only, that what is the frequency in India is. So maybe they can ask you that what is the frequency there. So that is 220 volt and 50 hertz. Okay, I'm just telling you thoroughly.
Okay.
Or you can write it in your notebook if you want it. Okay, so frequency is 50 hertz in this question. The next question is RMS value. What is the RMS value?
RMS value over here will be 300 by root 2, right?
Yes, good. That will be E of RMS. Actually, I should write here is that RMS value of E of t. Okay, I think
Yeah.
it is better. Although if it is nothing given, so obviously it is asking about that. 300 by root 2. You can rationalize it if you want it. I'll just show you some little things that the options can be made something like this also. Okay. RMS into this volt. Understood? So this is the V, and the average value for complete cycle is?
That's 0, right?
Yes, E of average for complete cycle. Cycle is 0, and average value for half of the cycle is?
So 600 by pi.
E average for half cycle. Yes, that will be the answer. That will be 2 by pi times of E naught, that is 300. So that is 600 by pi. Okay, I'm not solving it. 600 by pi. So this will be the complete question here. Okay.
Okay.
Should I ask you a good question? Do I
Sure.
have a time? Do I have the time? Let's see, I'll give it to you. We'll get this problem in the assignment also.
Okay.
This is a very popular one, but let me see. I can do. Actually, the signal is reaching from here to here. Can you imagine this square wave was traveling? Can you imagine
Yes.
the diagram?
Yes,
Hmm?
sir.
This is the signal was looking like this. Let us assume PV 2 volt, this to be minus 2 volt. This is E of t. This is time period t. Let it be 1 second. This to be 2 seconds. This to be 3 seconds. Calculate the I. This is the, let mark it as question. This is a good question. Okay. It is a good question. Calculate the ERMS. Now you require the
ERMS.
definition here. You require the
Yeah.
definition here.
Definition.
Think about it. The mathematical formula that I had given to you, you must apply that only, then you can get the answer. Should I give you a look of that formula? This is the formula.
Sir, I got it.
Have you written this formula?
Yes,
Should I
sir.
jump onto the question?
Yep.
Now, how will you find the RMS value? See, I'm telling you, just remember this, how we are applying it in the graph. Whenever I'm talking about the RMS formula, first of all, just apply the formula. There is a big under root there. And what you have to do is you have to do the, okay, just let me write here first. ERMS is under root of E of t whole square into dt divided by d of t from time 0 to t, and this is also integrating from time 0 to t. Yes or no?
Yeah.
Okay. Now see, if we'll integrate this, I'm just going to distribute into other parts. 0 to 1 E of t whole square dt plus E of t whole square dt, this for the time 1 to 2 and this for the time 2 to 3, that is E of t whole square dt, and whole divided by the time period that will, if you'll integrate it, you will find it out 3, because 0 to t dt is same as 3. Understood?
Yeah.
Now see, for the definition 0 to 1, the E of t is 2. Yes or no?
Yeah.
In the time 0 to 1, the E of t is 2.
It's 2.
You will find it out be 4. The next, it is minus 2. You will again find it out to be 4. For next 2 to 3 seconds, it will again be 4. You will find it to be 4 under root. Yes or no? Okay.
Yeah.
It will be this. Okay. So it will be nothing but 12 by 3 and get it
So
as
2.
2 ampere. Okay.
Okay.
This is how we used to calculate the ERMS. Understood?
Yeah.
I think this much is sufficient for today. And we had seen a lot of things. Okay. I'll assign you the homework right now, not after half an hour. Okay. I'll assign you the
Okay.
homework questions, and you get to see it over the portal there, right?
Yeah. Yes,
Online.
sir.
Okay, okay.
Online.
I'll
So
write the.
I had a doubt. The chapters that I had done previously, could you send the resources for that as well? Like you said, you had questions, right?
Resources. Like, see, I have a lot of questions, a very large book of a set of questions I'm having. And if I'll give you all the things, so you are going to just come to me again and again said, I am unable to solve this, I'm unable to solve it, because I had not taught that. So I don't know that how much your preparation is. Okay. So I'll
Yeah,
give
I
you
see.
some of the questions. I'll not give all of them. because
Yeah.
see, if I'm teaching something, so I know that how much conceptually I had built you, so I can rely on that particular thing and can give you my homework questions. But if I had not taught you something, so that sometimes feels me like that if I give you, that will overburden you and will make you feel that you don't know anything. Okay, so that is why I don't give I'll not give you the all of them. I'll give some of them. Okay, which chapter
Sir,
do you
by the
require
way,
it? Hmm.
yeah, sir, is it possible after this chapter we could do both chapter 3 and chapter 4 after the chapter?
Simultaneously?
No, not like simultaneously, like instead of continuing with the chapter that is
Yes,
after
yes,
AC,
yes,
can we
yes,
do
yes.
chapter 3 and chapter 4 instead?
Yes, yes, yes. We can
Yeah.
definitely do that. But if we'll do that, will require more time also for the completion of syllabus also. Okay, so
Okay.
maybe it will be required for to increase the number of classes if we are studying it the previous one chapters that you had already completed. See, because the time does not permits us
Yeah. No,
to teach
just the
in
third and
this.
fourth chapter.
Okay, okay, we'll do it. Don't worry. We'll complete the whole syllabus. Even after completing the syllabus, if we it gets the time, we'll also revise that. Don't worry for that. Okay.
Yeah.
Okay, okay.
Okay, sir.
Just do the homework that I'm going to assign you and ask the
Yeah.
doubts to me